Now, today we're going to start talking about triangles, and specifically today we're going to talk about the relationships between the measures of the angles in a triangle. So the first thing we're going to talk about is the triangle angle sum. This is probably something you're familiar with, but we'll go over it anyways. And if I were to measure all three of the angles in this triangle, so angle A, B, and C, and add them all together, they'll always add to 180 degrees. It doesn't matter what the triangle looks like. If it's a triangle, then the three angles will add to 180. So here I'm going to measure the three angles. You can say I'll move them around and they'll change. And then I'm going to add them all together. When I add them all together, I get 180. Now I'm going to move a point, and you'll see the angle measures are changing, but this value down here, this addition, is not going to change. They're always going to add up to 180 degrees. So it seems like a small fact, but it's very important. It's something we'll use constantly this year. So you need to remember that all three angles in a triangle add to 180. And one thing you can do is, if you know two angle measures in a triangle, you can always find out how big the third angle is. And that's something I'll tell you throughout the rest of the year. If you have a triangle, or in your picture there's a triangle, and you know two of the angles, always find the third angle. Usually it will help you out in a problem. So here we know two of the angles, 30 and 78, and we want to find the third one. Now, you might be able to do that without doing any sort of algebraic work, but it's good to get used to writing out an equation, because we know this is going to get more complicated. So I'm going to write out the relationship that if I add the three angles, they should add up to be equal to 180. And I'll simplify, and then I'll solve to find that missing one as 72 degrees. Again, this is something you could probably do really quickly in your head, but it's good to get used to writing the equations for when this gets more complicated in about a minute. Same idea here. The triangle looks different, but we can still do the same thing. If we know two angles in the triangle, we can always find out how big the third one is, because all three of those should add to 180. And I can simplify and solve to find that missing angle measure to be 24 degrees. So I promised I'd make it more complicated, and here we go. It's not terribly complicated compared to the last one, but now we do have an expression as one of the angle measures. But we solve the problem the same way. We have the three angles in a triangle, so they should add up to 180, so I can express that through this equation. I'll combine these like terms here, and then subtract 180 from both sides to find out that x is 0. So in order for these three angles to add up to 180, x has to be 0, which means this angle is just 54 degrees. Same idea here, maybe cranked up the difficulty a little bit, but I know the three angles. I know the measures of two, and I know that the third measure is 7 times x plus 1. So I can use the relationship, show that adding them together, they should add to 180. Simplify and solve that equation to find that x is 8. So if I wanted to figure out how big just this angle was, I could just use 42 and 81 like we did on the previous page and figure out how big it is. Or, now that I know x is 8, I could plug 8 in here to find out how big that angle is. So I want you to find the value of x in this triangle using the same methods we just used. Make sure to just type only the value of x when you answer the question. So we have one more angle relationship to talk about here, the exterior angle theorem. So the exterior angle theorem says that if two angles in a triangle are added, their sum is equal to the exterior angle at the third vertex. So let me show you what that might look like. Right now I have the same triangle as before, and each of these angles represents a vertex of the triangle. So a triangle has 3 vertices. But I want to draw an exterior angle. Right now, these angles are inside the triangle. They're called interior angles. But if I were to extend one of the sides, what happens is I create angles that exist on the outside of that triangle. And so if I measure angle A and angle B, and then I add angle A and angle B together, those two angles are equal to the measure of this angle BCD. So if I add angle A and angle B together, when I add them, they're going to be the same measure as this angle out here, the exterior angle that exists at the third vertex. So I measured A and B and added them. My third vertex is angle C at angle C, and so when I add these, it's equal to this exterior angle. So let me move this around a bit, change the measure of B, and you can see that those two values stay the same. Still moving things around, and those two values stay the same. So I wanted to show you sort of where that relationship is derived from. So I could find the measure of this angle, and that is angle ACB right here. Right at this point, it's 48.79 degrees. That could change based on how big A and B are. These 3 angles should add up to 180. So I measured all 3 of those angles and added them up, and they add to 180. The same thing is true about this missing angle and the exterior angle. Those two, they add to 180. So by using some substitution, if I know that these 3 add to 180 and these 2 add to 180, I can sort of cut out the middleman, this measure of angle ACB in both, and say that these 2 are equal to that one. So that was sort of a longer way of saying what I set up here. Add these 2 together, it should be the same as that exterior angle. So let's look at that in practice. I have 2 interior angles. I know one of them. And at my third vertex, I have an exterior angle. So I can use that relationship to find the missing angle. Those 2 interior ones add up, and they're equal to the exterior. And a quick solve finds this angle to be 87 degrees. Again, writing the equation is good practice for when this becomes more complicated. Same idea here. I know 2 interior angles, and I know the exterior angle located at the other vertex, the third vertex. So I can write that equation. Add the 2 interiors, should be equal to that exterior angle, and solve to find that interior angle at vertex V is 65 degrees. So, of course, we'll make it a little more complicated. The relationship still holds true. This angle represents angle W and angle V, and at angle U, I have the exterior angle. So I can add those 2 together and make it equal to the third one, or the exterior angle. Combine like terms and solve to find x to be 9. Again, 2 interior angles at vertex E and F. I have my exterior angle located at angle D. So these 2 add up to be equal to this one. And now I just have to solve this, the multi-step equation. I combine the 50 and the -4. Subtracted 2x from both sides, subtracted 13 from both sides, and divided by 3, and found that x was 11. So give this one a try, just like we did in the last couple slides. Use the exterior angle theorem. Make sure that you just type the value of x. And make sure that if you have any questions from this lesson, that you write them down in your notes so that you can ask me the next time you see me, and I can help you through that.